Hello my dear students, welcome back to Learn Physics. In today's video also we are continuing with our ray optics portion, and in last class we discussed about lens maker's formula, lens equation and magnification, different formulas, and combination of lenses is if two lenses are coming together or two or three lenses are there, then what will be the net effect of what will be the total effective focal length. 1 by f equals 1 by f1 plus 1 by f2. Okay, using these formulas, how we will be solving the numericals for your CBSE, that is NCERT syllabus. As per NCERT syllabus, which and all questions are there in based on this portion. Okay, that one we are going to discuss now. So here, the image obtained with a convex lens is erect and its length is 4 times the length of object. If focal length of the lens is 20 centimeter, calculate the object distance and image distance. So here in the question it is given like convex lens is erect. Yes, from giving an image of erect image. If it is erect image means magnification will be a positive value. Erect image means magnification will be positive. And the length of the 4 times the length, and its length is 4 times the length of object. So HI by HO will be 4. That is, magnification is given as plus 4. Length of image is 4 times that of object. Okay. Then if focal length of the lens is 20 centimeter, focal length is 20 centimeter, find the position of, calculate the object distance and image distance. So how can we calculate the object distance and image distance? Object distance U and V. See, M is 4, focal length is given. See, here we have direct two formulas. M is, these are the uses of these formulas. Otherwise, you should find out the equation and then substitute. Better than that, you can save time using these formulas. M equals F divided by F plus U. M and F are given. So, while you are substituting directly, you will get the value of U. And here M equals F minus V divided by F. Substituting the respective values, you will get the value of V also. Here 4 equals 20 divided by 20 plus U. Therefore 20 plus U equals 5. U equals 15 centimeter. Right? Then next is here M equals F minus V. So 20 minus V divided by 20 equals 4. So here 20 minus V equals 80. V equals 20 minus 80, that is equal to minus 60 centimeter. So here 20 equals 20 plus U equals 5. So 5 minus 25. So here U also negative because it is coming to this side. 5 minus 20, that is equal to minus 15 centimeter. So it is 15 minus 15 and minus 16. Both are at the same side. So it will be an erect image. Clear? So you can by heart these two formulas over here. Next question is, use the following ray diagram. Calculate the focal length of the lens. So the ray diagram is given like this is L1 and this is given as L2. Here focal length is 15 centimeter. This is the principal axis. Here it is O. So from here we will be getting an image here. I dash. So we are getting an image here. So this image will be acting as an object, right? So from here again it is getting deviated and will be getting a position over here. This is the final position of image. This is actually not forming. This first lens L1 is making an image at I dash. That I dash will be acting as an object for the second lens. So here final image we are getting over here, and here it is given like U is 40 centimeter, and this distance is given as 14 centimeter, and the image distance is given as 30 centimeter. Calculate the focal length of L2. How can we find out this one? See, first you should identify which and all our data are given. So for L1, focal length is given as 15 centimeter, U equals minus 40 centimeter. Since it is at the left side, U equals minus 40 centimeter. 1 by F equals 1 by V minus 1 by U. Therefore, 1 by V equals 1 by V equals 1 by F plus 1 by U. Therefore, 1 by 15 plus 1 by minus 40. Here we will get it as minus 40 plus 15 divided by 15 into 40. Here we will get it as 25 divided by 15 into 40. So here 5 5s are 25, 5 3s 8. 1 by 24 you will get. So we are getting V value as this here also negative, right? So we are getting it V value as 24 centimeter. So from here image distance L1 till I dash, image distance we are getting it as 24 centimeter. We need to find out the focal length of L2. From the second lens till image we have distance 30 centimeter. So for L2 image distance is given as 30 centimeter. So what will be the object distance? Here this will act as an object for the second one. From the first lens till I dash we have 24 centimeter. And then what will be this distance? Here to here 24, here to here 14. So what will be this much distance? It will be 10, right? So L1 to I dash, here it is 24 and this much is given as 14. So this will be 10. So U is given as 10 centimeter. Now we can substitute the formula 1 by F equals 1 by V minus 1 by U. Therefore 1 by 30 minus 1 by 10. So 300 will be 20 minus 20 divided by 300. So minus 1 by 15, F you are getting it as minus 15 centimeter. So focal length, what is that? For a concave lens, focal length will be negative, minus 15 centimeter. Clear? Next question is, 3 lenses L1, L2, L3, each of focal length 30 centimeter are placed coaxially as shown in figure. F is 30 centimeter. An object is held at 60 centimeter from the optic center of L1. The final real image is formed at L3 at the focus of L3. So final image is formed at the focus of L3. Calculate the separation between L1 and L2, then L2 and L3. This is first one. We should find out the separation between these two. So focal length of each lens is given as 30 centimeter. Here for the first lens, C1 or L1 I am considering. Focal length is given as 30 centimeter, positive, convex lens, right? So it is positive. U is object distance minus 60 centimeter. So what is the value of V here? 1 by V we can find out. 1 by F equals 1 by V minus 1 by U. 1 by V, how we can find out 1 by V? 1 by V equals 1 by 30 plus 1 by minus 60. Plus 1 by U it will become, and minus 60 when we are substituting here, we will get it as 60 is the LCM. So here we will get it as -2 and here +1. So final answer will be V equals 60 centimeter. So from here we will be getting an image at 60 centimeter. So for this one, suppose I am getting an image for the first lens. Images at 60 centimeter. Here what should we find out? We should find out the focal length, what is the distance between L1, L2 and L2 and L3. L1, L2, then L2 and L3. Final image for L3 is forming at the focus. If this image is at the focus, where will be the position of the object here? The ray is incidenting parallelly. The rays which are incidenting parallelly to the principal axis will form an image at the principal focus, right? So for L3, the incident rays are parallel. Incident rays are parallel for L3. Right? If we are getting a parallel output over here, the lens will be the image will be starting from, object will be placed at the principal focus of this one. Right? For the F2, this will be the position of F2. At F2, from F2, if the ray is incidenting from going from principal focus, after refraction it will be going parallelly. So then only we will be getting a parallel rays and it will be focused over here. So what will be this distance? This distance is 30 centimeter. And here we are getting V as 60. So the image formed by L1 will be forming at the principal focus of the second one. Got the point, right? Here the final image is forming at the principal focus of L3. If we are getting an image at F principal focus, the rays will be incident rays. Incident rays will be parallel rays. If we are getting a parallel rays over here, what will be the incident rays? Will be coming from the principal focus. That means the object is forming an image at the principal focus of the second one. So what will be the distance between L1 and L2? So distance between L1 and L2 are 60 plus 30, that will be 90 centimeter. And what will be the distance between L2 and L3? Any one convenient distance we can take because it's parallel rays. Okay, so we are considering it as any one convenient ray. Like that will be parallel at any position. We will be getting the principal since it is incidenting parallelly. Clear? Next question is, a beam of light of wavelength 400 nanometer is incident normally on a right angled prism as shown in figure. It is observed that light just grazes along the surface AC after falling on it. If refractive index mu of the material of the prism varies with wavelength lambda as mu equals 1.2 plus B by lambda square. Calculate the value of B and mu. B and mu we should find out of prism of material for wavelength 500 nanometer. Given theta equals sine inverse 0.625. These are the data given. Now I will draw the diagram. See here, right angled prism and the ray is incidenting like this. This is at 90 degree. This is theta, A, C, this is B, here also 90 degree. Okay, and a beam of light of wavelength 400 nanometer is incidenting 400 nanometer is incidenting normally on a right angled prism, and it is observed that light just grazes along the surface AC. Okay, and the refractive index of the material of the prism, and B we should find out for wavelength 500 nanometer. right? So these are the data given. If a ray of light is incidenting at AC and it is passing through AC, that means the incident ray is here angle of incidence will be the critical angle. N equals 1 by sin C. This is the formula. Right? Here refractive index they are given it as mu. So it is 1 by sin C. Here what is C here? Instead of C they are given it as theta. So it is sin theta. So from the given data, theta equals sin inverse 0.625. So what is sin theta? Equals 1 by 0.625. That is the n value or refractive index mu. I can write it as mu also. Now we need to find out mu and B for wavelength 500 nanometer. So mu equals 1.2 plus B by lambda square. So we don't have B and mu. Both the values we need, right? So from using 400 nanometer, first we can find out the value of B. Because mu is given as 1 by 0.625. 1 by 0.625 equals 1.2 plus B by 400 into 10 to the power minus 9. You can calculate B as 1 by 0.625 minus 1.2 into 400 into 10 to the power minus 9. You can calculate B from this. Okay. After calculating B, you can substitute over here. Mu equals 1.2 plus this B value divided by 500 into 10 to the power minus 9. So you will get the value of nu n. I'll give you the values for the B value. You will get it as 64,000 Newton meter square. Okay, here you will get it as 64,000 Newton meter square and 64,000 nanometer, not Newton meter, nanometer. Nanometer while you are substituting 10 to the power minus 9 only here also you will be getting, and while you are calculating you will get n value as 1.45. Okay, 1.45. This will be the n value. Clear? Next question. A diverging lens of focal length f is cut into two identical parts, each forming plano-concave lens. What is the focal length of each part? So we have a one diverging lens and it is divided into two equal parts. So here this is a diverging lens and it is dividing it into two parts. What is the focal length of each part? How can we find out? So we know that the formula for this is f is the focal length of this diverging lens, then 1 by f equals n minus 1 into 1 by r1 minus 1 by r2. We know that r1 we will take it as minus r and r2 we will take it as plus r. Right? It is biconvex lens, biconcave lens, so we will consider like this. Now 1 by f equals n minus 1 into 1 by r1 is minus r plus r2 is minus r. Okay, therefore n minus 1 you will get it as minus, we can take it outside, 2 by r. This will be the formula. Okay, now if I am dividing it into two equal parts, so the everything will be divided into half, right? So 1 by f equals n minus 1 into 1 by r1. 1 by r1 is minus r. r2 is infinity, 1 by infinity. So here we will get it as 1 by infinity is 0, n minus 1 divided by r, that is equal to 1 by f. In terms of capital F, how I can write n minus 1 divided by r is, so f equals r by n minus 1 and here capital F equals r divided by n minus 1 into 2. So how it is related? If I am dividing both, I will get it as f divided by capital F equals taking the reciprocal and multiplying. So focal length will be twice that of the initial one. Small f equals 2f. It is dividing it into two equal parts, right? So we will be getting focal length is twice that of the previous one. Clear? So here, if it is a plano convex lens means one side will be infinity. Focal length, the radius of curvature, we will consider it as negative. So infinity, why? Because it's a plane sheet. Okay, clear children? So these are some of the numericals related to your topic, and I think all these are useful for you. In the next video, we will be continuing with our prism, how the questions will be asked, that and all we will be discussing. And if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.